All right. Good morning, students. We want to start our session for today. Karibuni sana. Thank you for coming in into the online meeting or online session for multimedia class. So we just go ahead and start our session for today. And yes, so well, this should be spelled correctly, not VE, but VI, video. So we'll be looking at the role of video in multimedia, just looking at a few issues that are important to consider when we want to add video to a multimedia presentation. Okay, so let's first of all confirm that our audio is good. If I can have some chat there, a text to let me know on this end whether you are getting the audio clearly enough on your end, so that we sure. Yes, thank you so much. There is a confirmation there from several of you. Thank you so much from Wangi, Anna there, Marcy, and Victor. Thank you so much, Bravin. So we ready to move on. Thank you so much. So I'm going to now before we come to the video, let me first of all take us back to audio briefly. The audio briefly. This especially there is just some part of the audio that we did not look at, but I also don't intend to look at it in detail about MIDI. So there is the concept of MIDI, or a technology called MIDI. Yes, thank you, Sammy, as well, confirming our audio is good. I'm glad that that is the situation. So MIDI, so let me first of all mount the document that we are using for MIDI. I mean for audio. Sorry, for audio. And I just highlight one or two things about MIDI. That is MIDI, without using too much time on that. All right, so this document, we used it for our audio when we were looking at the audio. So it's loading good. I think the system is good. I think the network is also very good. It's loading quite fast, and that's very good. It's very helpful. Thank you. We can look at this briefly, and then we continue with the video. So this one, as I said, I just want to highlight one or two things. So audio, this is the document we used for a discussion on the audio. But there is also something about MIDI, M-I-D-I. Just want to revisit that very briefly. Sorry, I think it is not scrolling very fast. No, I went too far on myself. All right, so MIDI, there is the concept of MIDI. And MIDI, as it says, MIDI is actually an acronym, M-I-D-I. And it says it's a musical instrument digital interface. Musical instrument digital interface, and this is a kind of a device that captures. Mainly, this is meant mainly for instruments rather than somebody singing. It's more for instruments, as you can see. It says musical instrument. All right, so musical instrument. So it is meant for capturing what we can say. Now it's essentially it's the notes, because it is not meant to capture what the sound that an instrument is making necessarily. It is to capture the note. Now this of course is a bit music. There is something called music that people study, and they can talk about the notes and all sorts of things that relate to how sound is made. We talk about the soprano, the alto, all those kind of things, details related to how music is constructed. But so this is not so much about sound. So this MIDI is more about the notes, saying that the note, and then it is of course captured and stored in a digital format, because again it says digital. So it's more about capturing what notes are being used in developing whatever the music that is going on. But again, as we're saying, it's more about instruments rather than somebody singing and producing a sound. And even for the instrument, it's not about the sound that the instrument is making. It's more about the those details about, there's something called notes, the notes that are being used to create that sound. So it is more interested with the note. In other words, the instrument itself. It is about the, I think the best analogy here is about the keyboard, or even the guitar. But let's say about the keyboard, and you press a certain button. So that button, the way it is pressed, has its characteristic sound that it makes. So that characteristic is what is important in this case, rather than actually the button itself. Of course, the button and the characteristic will be important. So this particular device, which we're calling the MIDI, captures the notes that somebody is maybe let me call it pressing, relating it to the keyboard. So when I press a certain button on the keyboard, it kind of it registers that, and of course not the button, but the note that button produces, and that is what is stored in a digital form. And for some of us who may be a little more familiar with these instruments, and of course now we are talking about things like electronic guitar, and a keyboard that is also capable of being electronic in some way. But of course, it's not just electronic. There are some electronic guitars, for example, which are not really MIDI. So it is not just electronic. It also has to be what we are calling a MIDI. It must be MIDI. It should be able to communicate with the MIDI system. So this is what we're talking about, MIDI. So MIDI is about instruments, musical instruments, and when the device stores what is happening with that instrument, it stores the notes. Actually, we call them events. It stores events rather than the sound that was made by the guitar or the sound that was made by the keyboard or whatever. Of course, if you have a MIDI drum as well, things like that. So it is more about the notes that are being pressed here and there. That is what it stores. Now, what is the importance of this? Is so that once if you connect one instrument, which is MIDI, at one point, of course, I don't know whether we have a diagram here. Unfortunately, I don't think we have a diagram of that interface. That is not very good. I should have looked for one. But anyway, for some of us who have attended events, I'm sure you have seen some of these devices where whoever is controlling the music in an event, normally they have these MIDI devices, and then they cannot connect maybe whatever the instrument they are using. Most of the time I see many people have a keyboard. Sometimes there is also a guitar. So then they can connect. Now, if you have several instruments that are MIDI, and then they are connected to the MIDI device, you can play only one, and all the others also kind of create their own sounds. It seems like if they are connected, then you can, if maybe one person, the one who is playing only the keyboard. But if a MIDI guitar and a MIDI drum system and all other instruments are connected to the MIDI, then you'll find that it can create the sound for all of them. Because once the keyboard is pressed and creates that note, then that note is now sent to all the other instruments. And so now the drum plays the same note on its own, of course. The guitar plays the same note on itself, by itself, etc. So that you find that somebody is playing only the keyboard, but when you listen, it's like they are all instruments, so several instruments that are being played, because the MIDI is supposed to help instruments to communicate to each other. So if I'm having a MIDI keyboard and I press a certain button, that it communicates with a MIDI drum, a MIDI guitar, a MIDI whatever else might be there, and they all play the same note. So you'll find that you are hearing the sound of several instruments, and yet it's only one instrument that is being played. So that's the concept of MIDI. I don't intend to take much time talking about it. So the MIDI, musical instrument digital interface, that's how it works, and of course it has some benefits. So it says the MIDI is a shorthand representation of music stored in numeric form. It is the form of music score. It is in the form of music score, and not samples or recording. It is not digitized sound. It is, of course, purposely for music. And so normally we have these two words, the sequencer and synthesizer. So the sequencer it says a sequencer is a software. A sequencer software and sound synthesizer is required in order to create MIDI score. So the synthesizer is the instrument. A sequencer is a software that can record and edit a sound of any kind, of course, including the MIDI. Now, once the MIDI, whatever we are getting from a MIDI instrument is now stored in a digital form, now we can also edit that by using a sound synthesizer. Of course, the sound synthesizer should be able to edit even other form of sounds. Okay, so the other thing that is important to note about MIDI is that MIDI files are small. They are very, very small. So they are very good in terms of sending them around. For example, in web pages, embedding them in web pages, or simply when you may want to send them to somebody across the internet. They are very small, and so they are that is a big advantage about the MIDI files. So I think the rest of these I'll let you just read a little more on your own. Recording MIDI files. Some of the audio file formats for MIDI. Of course, where this is a mixture. So the MIDI ones, so they take certain what you call file extensions. Then, of course, these are just now ordinary music. In music, of course, now this one will capture both instruments as well as if somebody is singing. So it's just a usual audio digital. So we have several audio files like .wav is very popular. We see it all around because most of the people are using computers that are running the Windows operating system. And so we find that we get a lot of these .wav files. But of course, we have several others also from other operating systems. So with the Mac, there is that one, .aiff. In the Unix, they have .au, etc. So, and of course, there's this one which is very popular, the MP3 file extension. So this is also we find it quite a lot, this one, because this one actually is more of what we call a compression format. It is actually the others being compressed. You compress them to get an MP3. So it's a compressed type of data, the MP3. All right, so I think that's all I should say about the audio. But look at this section. I think you may already have looked at it, but look at it again, just in case there are some things that you are not familiar about earlier on, and you getting to understand it better as I explain it. So read also about the differences. What are the differences between MIDI files or MIDI data and digital audio? So digital audio is the ordinary sound, the way we speak, any sound that is recorded, the sound itself, rather than recording the notes. So it's good to do that comparison. All right. Audio sound to multimedia project, of course, now is just talking about issues relating to how it is stored and other advantages and disadvantages. Okay, so that's all I can say about MIDI. It's more of a recap from a previous lesson on audio, digitizing audio, and all those issues. Okay, so we now move to look at video. I think I pressed I removed myself from the meeting by mistake. Okay, so I think we can now load the document that we want to do for today. We want to look at video in multimedia. What are some of the issues that we need to understand about video, and also in terms of applying or adding video to multimedia presentations. So we have the document is already displaying. So video, we familiar with video already. Video is now popular, very popular. Of course, the technology of having a video is changing. Initially, we had videos that would only produce what was called analog video. And most of the time that was based when we wanted to store video, we would have the video would only be in the form of some tapes. you'd have some tips to store the video. And of course, that was those days. We can't say anything about that because technology is always good, but it keeps on changing. So of course, things are changing. And now we have moved to digital video. So a few years back, we could only have analog video. An analog video would mainly be stored in what we called tapes or video cassette, and then we have video players and video recorders. But now we have moved to the digital. We have digitized everything, so that we have now the video cameras are meant now to store the data digitally rather than have it as a analog. But a few years back again, when converting from analog to digital came about, many people were doing the converting. If you had an old video, then you would try to convert it so that you can store it now in a CD, and then you play it now from a CD at the computer. You see now with the analog video, which was in a cassette, you could not use the computer to play it because the computer does not have or is not made in such a way that you can play a cassette or a tape, something that is tape. So when the technology came up, initially what the people did is to have, there was a machine that could change the analog, whatever is analog, which is coming from a tape, change it to a digital format and store it in a CD. And so that happened. But nowadays, now you have devices that can do the digitization automatically. So if there is a video, now we do have cameras, video cameras, which automatically convert whatever they are recording into digital, and then it is always digital by the time it is all done. If it's an event that one is recording, by the time the event is done, everything is already digital and can be put. Maybe can of course people sometimes they have some small cards which are used to store the recording, but then that one can be put immediately in maybe a DVD or whatever somebody has that can hold the data that has been stored, but which is already digital. So nowadays, therefore, we now operate with the digital content, video, which is already digital content. It becomes a little easier when it is digital. First of all, it does not require as much storage as the one which is analog. The other thing is that it can be edited and changed into so many different ways. You can just capture just a small section of it, which you may need at a certain point. So when it is digital, it becomes a little easier to do a lot of things to what has been recorded. But yes, this is just video. Video is a video that we know. Then we have even small devices like now mobile phones have a video capability. And of course, I'm sure you are already familiar with that. You can actually take a video with the phone. Now, the only problem is that the issue of space becomes also critical. So even when it is digital, now space is still an issue. But of course, it's not the issue is not as a major challenge as the analog. So as we look at this, I'm not intending to take a long time on this one as well. And so some of the materials that are here, I will leave to the student to refer to and read and make sure that you capture the whole essence of what the document is trying to say relating to video. So as most of the things that we need to say in these first slides, I've already said, and so we already are done with that. All right, so analog video, I've already said about analog video. So video information that is stored using television video signals, film, videotape, or other non-computer media. So this analog video, so as I said, it was normally, once it is captured using a video camera for that technology, then it would be stored in a tape, what we are calling the video cassette. It was also called the video cassette. And then the device that was recording, it would be called the video cassette recorder, VCR. And so then it would, one of the things that it does is that when it creates, when we are capturing a video, essentially we are capturing, it's just like the camera, the ordinary camera for photos. So, but then we capture very many photos, so to speak. Within a short time, you capture very many. You can call it, you are taking so many photos, but within a very short time. And now once it has been taken, for the video, whatever you take, now we call it a frame. What you have taken, that image, we normally use the word frame. So we don't call it a photo, we don't call it a picture. Of course, it's an image, but now the whole thing that you have captured, each of the photos taken by the video camera, at the point of now displaying it, maybe you have whatever is going to be used now to watch the video that has been taken. When we are looking at those images that are coming at our screen, now we call it a frame. So that's what it's saying here. Each frame is represented by a fluctuating voltage signal known as an analog wave form or composite video. Now this is talking about analog. This part is just discussing about analog, but yes, there is the same word that we use even we go digital. So I don't want to talk too much about the analog because our focus is more on digitizing this video. Just like we talked about digitizing sound, we want more to focus on digitizing the video. And as I said initially, what we do is to get our old analog videos and then convert them to digital. But nowadays we have instruments, we have devices which will record the video and automatically also store it as digital. So digital video is a digitization of analog video signals into numerical format. It creates the illusion of full motion by displaying a rapid sequence of changing images on a display device. And so with the digital, here it's not, the other one was talking about fluctuating voltages. So with this one, that's the actual, it's these images, the images one by one. Now, if you have several images, moving quite fast at the screen, we will not realize that it is several images that are passing in front of our eyes, and that's what we are calling the illusion of full motion. Okay, the illusion. So the eye is not able to detect that what we are watching is several images that are being brought, in front of us by whatever the screen that you are using. So what we do is have very many images changing within a very short moment of time. as we'll see in a short while, is that these images are about at least, they should be at least 15 images per second, passing in front of our eyes. Now, if they are at that speed, you not notice that it is images that are being changed one by one. And so you'll just notice now whatever the action is happening. So if it is you're watching football, you don't see that was an image where somebody was about to lift their leg in order to kick the ball. You just don't see that was an image. Somebody is lifting leg. Then another image, now they are the leg has, or the foot has touched the ball, and the next one the person has kicked. No, you don't see that because the images are very, they are moving at a very high speed. So the only thing that you see is just like the only way that you see somebody coming and kicking the ball. So that's what we are calling the illusion. You don't see the motion that you are seeing does not look like images being changed, but it's going smoothly. But that is what we are calling the illusion of motion. So when you are watching a video, it is based on illusion. The technology that is enabling us to watch the video creates what we are calling the illusion of motion. It cheats us that we are seeing a smooth motion, whereas actually it is just images that are being changed within a very short time. But of course, remember, these are images that are also taken within a very short time, many of them. And so you can't differentiate that the two are not the same image, but they are actually images that are captured within a very short time. And then we also play them in the same, almost the same, at the same speed. Okay, so conversion from analog to digital format requires the use of an ADC. So that's just the name of a general name for the converting device, a device that will change an image from being analog to digital. But remember, nowadays now we have a device that does that at the same time. We don't take the analog and then take it to somebody to make it digital for us. No. And of course, I'm sure you're already familiar with this, because most of you have a mobile phone that does this, takes an image, some kind of a video, a short one, of course, but you don't have to take to anywhere else for it to be converted to digital. Already there is a component within your phone as well, which is an ADC. So as soon as the image is taken, it is converted to digital. Whatever the video is, whatever you have recorded as video, as soon as you have it recorded within your phone, again, it is also automatically converted to digital. So the ADC, therefore, is just a general name. It's not that there is something that you have to go and look at. It's just a technology. Of course, it has to be part of your phone, for example, or it's an ordinary camera that is meant for video recording, because of course there are those that are commercial. So the ADC is just a component within the same. It is not a separate component. Analog to digital converter. So that's a simple description of video. And what I want us to look at now is, again, we look at the whole process of digitization, but especially in terms of creating the files, and we also look at the issue about space. Videos can use a lot of space. So we want also to look at how can we estimate the amount of space that a video recording can probably need. How much space do you need to record an event for 1 hour? How much space, how much storage space will you need? And of course, this is an estimate, because of course there are some things things that we have to assume. So how much space do you need if you want to record an event for 1 hour? So that will be our main focus for this time. So anything else that is added here, a lot of this I'll leave the student to read through. So there is also the digital video compression, because the videos can end up being very, very huge in terms of their size, and especially in terms of the amount of space that you need to store what you have recorded. We always do digital video compression. And now this, we also talked about the sound. You need also sometimes to do the compression. Even the images also, we talk about compression. But video is even more critical, because video can become a very huge size within a very short time. The reason is because you are storing images. It's because you are storing images. Now remember, images are pixels, and we talked about the pixels when we are talking about the images. So we'll revisit that concept of the pixels, because the video is also images, and it is many images. You are storing many images within a very short time, because and that is the only way that we can cheat the eye that we are seeing movement. But essentially, it is not a real movement we see. Instead, what we see as movement is simply that many images are being displayed in front of our eyes at a very high speed. We call that the illusion of motion. So digital video compression, therefore, is important. We'll come back to this in a short while. So let's first of all come to the issue of looking at the issue about the size, and hope we have now when we are working out the size. So the size of video, size and formats. So when we think about the size, we have to think about the frame rate, the image size, because remember, the frame is actually an image, but when we are running a video, we call it a frame. Of course, there is a reason why the name frame is used rather than calling it an image. But you see, we still going back to the concept of the image, because these frames are actually images. And then there is what we call the color depth. So the color depth, now we come back to this concept again when we are talking about we are talking about images. And if the image is going to be displayed as colored image, then we have to talk about color depth. And we talked about the color depth. Now, as I said, when we are looking at the images, is that there is a bit of a confusion, because sometimes some sources will talk about color depth, and others will talk about the bit depth. But these are the same. They are used interchangeably to some extent, but sometimes it can create a confusion as to which is saying which is which. When I say color depth, do I mean the bit depth, or is it the number of actual number of colors that device can make? But anyway, so we'll use the two words interchangeably, color depth and bit depth. So the bit depth is the number of bits that are used to code a pixel. To code a pixel. So how many bits are we using to code a pixel? So I think with that, we can now look at how to estimate the size of a video. Now, the frame rate is the number of frames, or let's say that's a correct way of calling it. But let me also say is the number of images that are going to be displayed across, in front of our eyes, and change within a second. So how how many images are being run per second in order to create the illusion of motion. That is the frame rate. The frame rate. So here, instead of talking about the sampling rate, we talk about the frame rate. How many frames are being passed in front of us within a second. And those frames are essentially they are the images. So the images, therefore, is going to be important. So this image, the images that are being passed in front of us. So what is the size of each? Of course, they will have the same size, all of them. And then the reason why we need the image size is to know how many pixels, of course, are we dealing with. So this issue about the color depth is actually about the image. So unfortunately, I don't think we have an example, an obvious example here. So we have to kind of come up with just a theoretical case. I forgot to put some example here, but so we'll go to the whiteboard, and we just come up with an example that we can use. Right. So there are some details that are mentioned there. So the image size will be based on your whatever you are using to take your. Of course, there are two things when we are dealing with an image. There is the actual device that you use to capture the image, but there is also the place where you are going to look at the image. So like you take a photo with your maybe with your phone, and then you go and display it at your computer. You display it. Of course, you can also display it at your the same mobile phone. So there are two things. But here, so when it comes to the frames, it's the same. We have to think more of what actually captured the image. So the issues are here that are talking about resolution and all that, which we also need to consider when we are talking about the image size. So what is the image size? But the image size will actually more be based on what captured the image. Okay, so the frame rate is the number of images that are going across our eyes at the screen within a second. So we talk about frames per second. How many frames per second? Now, television and movies play at 30 frames per second, but acceptable playback can be achieved even with 15 frames per second. So they say that with 15 frames per second, this can still produce the illusion of motion. But if the speed of displaying your images become less than these, you'll start noticing that, oh, that's one image is gone, another one, another one, another one. So you'll lose the illusion of motion concept if the speed is too slow. And so there is the minimum that can produce the illusion of motion. Of course, the maximum, it does not matter. The ordinary issue with the maximum, I mean, the problem with the too many is that now where do you store that video that you are going to roll at such a high speed? So that will be the main issue. But if it becomes too few, then again it will lose the illusion of motion, will be lost. And so we need that frame rate. How many images are we going to be displaying per second? But also, and now remember, this will be dependent on what you are using to capture, because it's more about whatever you are using to record your video. So what is its frame rate? In other words, how many photos is it taking per second? And of course, you may need to have whatever you are going now to use to view and watch the video you have taken should have almost a similar speed, but it's not a must, but at least it should be high enough. So whatever you're using to capture your image, your video, what speed does it use? So we have, so that's what we are talking about here, frames per second. And that will be very important. Then, as we have said, is that image, each of these image, what is its size? What is the size of each of these images that now we are displaying at a very high speed across our eyes on the screen? And then finally, of course, as we have said, the color depth. How many pixels, how many bits do we is this device using to represent the color? Of course, each pixel, because the pixels are the ones which make the image. So each pixel, how many bits are we using for each pixel? The more than the bits, the more colors we can display. And that is a concept. Okay, so I think, as I said, I'm realizing we don't have an example in this particular document. That was something that I should have checked, so that we have an example that is in the document. But now, since we don't have one, we are going to try and just create an assumed case. So I'm going to go to the whiteboard and we try to come up with that. So we are the whiteboard. We go to the whiteboard. So I'm going to remove this screen share, and we go to the whiteboard and we come up with a case. Of course, we are going to use the approximate types of sizes. Okay, so let's assume a case. So suppose we are capturing a video so that this device, this particular video, first of all, we say what is a frame rate. This video, we want it to be running at, let's say, 30 frames per second, FPS. Okay, 30 frames per second. And we are going to assume a color depth or a bit depth. In this case, we're saying is the same. A bit depth and color depth for this case. Let's keep them the same. And that's actually correct. And this one is number of so number of bits per pixel. So how many bits are representing each pixel for the image, to create the image? So how many bits are we using per pixel? The other thing that we say, or it says we need, of course, is a image size. In other words, the images that we are using in the video, what is the size of each image? And of course, all of them should be the same size because we are using the same device. So all the images that we are creating at that point should all be of the same size. And that is where the word resolution is coming in. Now, resolution for the screens that we use is the way it is stated is in form of the sizes, the horizontal size of your screen and the vertical size of your screen. So you see, resolutions for monitors. When you read the concept of resolution for monitors, for computer screens, you see they are given in two numbers, like 640 by 480, or 800 by 600. Those type of numbering. And so let's assume that this video camera, or let's say it's even could be even although let's use a video camera. This video camera in this case would be a better one, so that we say it is going to be when it is displayed on your screen, it should actually cover the whole screen, rather than you see the way the one from the phone seems to use only a very small space of your computer screen, very small space, and narrow at the sometimes at the center there. So let's talk about the video camera, which is going to take a photo that can fill most of the computer screens. Now, and again, of course, that would depend on the technology that your computer is using. And so let's for now assume that it is going to be the one which the image can fill a screen that is 800 by 600. A 800 by 600. So that is the size of your that's the size of your image. Now these numbers, of course, mean pixels. These numbers mean pixels. They are not always written that way. They don't always say it is pixels, but that is what they represent. So it means that horizontally, you have an arrangement of 800 pixels. And horizontally, you have, of course, horizontal is more like rows. So it is 800. It's like you have 600 rows of pixels, and each row has 800 pixels. Now that would be a good way to look at it. You have pixels that are all arranged horizontally into rows across your screen, and you have 600 of those rows, 600. But on each row there are 800 pixels, and so it is very easy to calculate how many pixels therefore do we have. So this will give us 800 by 600. Of course, that is a simple calculation mathematically. That is 48 followed by 4 zeros. Pixels. Okay, so we have that will be the size of the image. Each image is going to be 480,000 pixels. Convert that one into bits. So you need to convert that one now into bits. You need to remember these conversions. So the image will be 48 followed by 4 zeros. Sorry, 4 zeros. So yeah, I'm using the O. So 48 followed by 4 zeros multiplied by now the pixels per, the bits per pixel. Oh, I think we forgot to say how many we are going to use here. Sorry, that one the notation we needed to also assume how many pixels how many bits do we want to use? So let's use 16 for now. Sorry, let me get this one right. Okay, so we are going to assume that our bit depth is 16. Bits per pixel. Oh, sorry, it is. I think my space is not. So let me just call it P bits per pixel, PP. All right, because of space there. Sorry, I think I did the wrong thing there. Sorry for that. Oh yeah, it's showing all right. Okay, so that's now the assumption is that our color depth is 16 bits per pixel, So here, therefore, we're going to multiply by 16 to now convert the pixels to bits, or the image size now expressing it in bits. So we multiply by 16. So what is the size of each image, each of our image? We have to now to multiply those two numbers. All right, that I think would be a good point of interaction. Let me have several of you helping us to do that calculation. What is 480,000 times 16? Actually, alternatively, let's convert it to bytes. I think that will help us to reduce the amount of calculations that we need to do. Okay, but then you need to first of all know that this will now be the size of this image in terms of the bits. So actually, let me write that. But let's reduce our calculation by converting it to bytes instead of using bits. And now you need to always remember that. Sometimes I see students are forgetting to convert your figures into bytes. So these are bits, but let's divide by 8 to make them bytes. So divide by 8. Which will give us now our final figure here. Now I think let me write it down here. So divide by 8 so that you convert, you stop talking about bits and talk in terms of bytes. So of course what you need, 16 divided by 8 is 2. So we are now making our calculation better. It is going to be better, but then remember that now it will be in bytes. So if you divide, you get a 2, then now it's our mathematics is becoming better, because now it is 48 or 480,000 multiplied by 2. 480,000 multiplied by 2, which I think we can say it's 96 followed by 4 zeros. But this now is bytes. All right, so I want to believe that we are following that. Any question this far? Let me give us a chance to ask a question of clarification at this point before we go on, so that I don't lose any of us. Yes, any question? Are we moving on well? Is this calculation clear so far? Yes, it would be helpful to get some confirmation, either yes or a question of clarification. Is it clear? Can we just move on? Oh, sorry, I forgot to put my image on the screen. Okay, so are we okay so far? All right, John has already given us a value there, and Philemona. Yes, Mwangi, Mercy, and Emmanuel. Yes, Gary. Right, Gianni Sami. Good, and many of you are also agreeing that is correct. Okay, but there is a question from Emmanuel. Is the 16 bits constant everywhere? No, not really. As you remember, you said we are just assuming a case. Remember, we have all these now in in the history of this technology, there has been very many values that have been used in the past. Initially, of course, it was just 1 bit per pixel. It moved to 8 bits per pixel. Now, 8 bits per pixel can produce 256 colors. So it has continued, of course, to improve. It went from 8 to 16, from 16 to 24, and currently we are now dealing with that 2. That 2 can produce billions of colors, and of course, if you are talking about billions of colors, some of them will have a very slight difference. But yes, in ordinary interaction with colors, we do talk about shades of colors. You can talk about shades of green, shades of orange. So that's why we can talk about billions of colors. It doesn't mean that they will be so distinct, but of course there will still be different colors. When the eye looks at whatever you are presenting, it will see that is a different color. All right, so I think we are in agreement. Thank you once again, Philomena, accepting. We can move on. And so this image that is 960,000 bytes. It's not so big. I think I may have seen something, but okay. Now converted then now to bytes. It can go to kilobytes. So we can now move it to the higher. Of course, again, it depends. Sometimes you are told to state it in a certain value. But this one, we are just doing it because we can make it, can use a bigger unit and convert it to kilobytes. So we divide by 1,000. So it's going to be 960 kilobytes. All right, it's going to be 960 kilobytes. Each image that our camera is the images that it is creating as it is recording the video. Each of the images it is creating is 960 kilobytes. So thank you, Emmanuel. Also has already also given that value. So 960 kilobytes. Yes, and Philomena has also added there's the same. Now, but when you put it in a symbols, it is a small k followed by a capital B, right? If you use a small b, if somebody is very keen on that, they will say that you are talking about bits. Now, notice the symbols. The symbols, b, small b is for bits. Bits. Now, when we are talking about the speed of our internet, normally it is bits. So you need to be familiar with that. When you see the small b is for bits, and then the capital B is for bytes. Anyway, but so that's if every image that our camera is recording is 960 kilobytes. Now, notice that it is making 30 of them per second. You know, 30, we say now, let our frame rate be 30 frames per second. So every second, your camera, which you'll be using to record your video, is creating 30 images per second. That's per second. So what will be the size, the total size of your images? The 30 images that your camera is producing per second. So of course, that's now quite straightforward. You can say so. Size of video. Now let's call it size of video now. So size of video per second. So every second of your recording, your video will be what size? Of course, it's at 960 times 30. Of course, this is 960 kilobytes by 30. That's a simple calculation. Yes, let's see another one giving us that. So what is 960 times 30? Yes, put at the chart. Let's have several of you put, even if it is put by one person and you agree, put another one as well. Or so you tell, or you write, I agree with so and so. Well, but we see some differences there. 3 responses with different figures. So now we need to check which is which. Because John Maganga has 28,800. Justus Mokwa has 198,100. Otieno Bryan has 29,80. Which is repeated by, okay, that's Justus Mokwa, yes, and repeated by Otieno Bryan, and also by Mwangi Hana. No, Mwangi Hana has the one of Justus. No, or the one of John. Now, this is my mathematics, so why are we having it different? This is mathematics. Linda says it is 28,800, so it stands with the one which came from John Maganga. Yes, this is mathematics, so I expect you have now Otieno Bryan is saying it should be 29,80, stands with Justus Mokwa. So, okay. I don't know which is which. I have not calculated. So let's have a final confirmation for me, because I'm not calculating. Yes, I think it should be 28,800. 28,800. It seems like that is should be the correct figure. Thank you. Also, Mercy Mwangi has also put, he was there. And Linda also has put 28,800. All right. So let's put that figure. I think the others just confirm and make sure that we are not using the wrong number or the wrong. So this will be the size of the video now per second. Per second. And sometimes we put just an S. All right. So this is going to be every second. That is the size of your video. Now remember, the video is a combination of several images. And of course, we need also to remember that the video also captures sound. Now, in most calculations of video, we ignore the sound, because in terms of the size, what actually is going to make up the size, of course, the sound is also important, but the core component that will determine the size of your video is the images. And so when we do the calculations, we sometimes ignore that this video has also sound, and the sound is separate. Remember, now we are only looking at the images. So the sound is a separate component, but we can ignore it in the calculations. All right, so every second, that is the size of your video. So suppose, therefore, you record, now if you want, you can convert that one to megabytes. Now it is big enough to convert to megabytes. All right, so we can try to convert this one to megabytes. Sorry. So megabytes, this of course just divide by 1,000 again. We get 28.8 MB. MB is capital M, capital B. Capital B, megabytes. All right. So you notice that already it is now at the size of the megabytes and it is just 1 second. So you can imagine that 1 second and it's already at the size of megabyte. So by the time you are done with your recording, it is going to require a lot of space. And I'm sure you must have tried to do a video with your camera, with your mobile phone, and you take just a few minutes, and your phone is saying no more space, because the video grows to a very large size within a very short moment, very short. So if you have just maybe already your camera, your mobile phone already has some other content, it is already starting to show that, oh, the space is small. So maybe you have like a GB still there showing at least some 1 GB that you can put some more content on your phone. But the moment you try to record it, a video with your mobile phone, within a short time, it is telling you that it is completely full. So the video grows in size very fast. So every second, 28.8 MB. So suppose we record for, let's say, 10 minutes. 10 minutes. So 10 minutes recording. Now we forgot to assume how long we want to record our video, but that now we can add here. Say, suppose we are recording for 10 minutes. Now that again is a straightforward. It's going to be a straightforward recording. So yes, you can be calculating that for me. So how much will it be per, I know in 10 minutes. Sorry, I think I'm trying to capture. Please, I'm trying to correct here. Okay, so somebody is trying to give us a calculation there. Right now, what is the recording in 10 minutes? I think it's now remember the 28.8 MBs per second. Of course, you have to remember that the 28.8 is per second. So if you record for 10 minutes, you need to remember that conversion. Okay. So somebody is getting. Now remember to put your unit so that we are sure which figure you are sending. Are you sending us the MB? And of course, you notice that once we reach a certain figure, it is better to start talking about GB. So that's how we keep going. Of course, if you have not been asked, you will not be penalized as long as the figure is correct. But we keep on moving to the next unit, as we see that now that will be the best unit to start using when we look at our figure. So I would think that at this point we should now be starting to look to put our figure in gigabytes, GB. Since your figures are already at the GB, we should now start putting our figures in GB. Okay, so in GB, therefore, of course, all your figures look correct. And in terms of MBs as well as in terms of GBs, I see all our figures this time are good. They are correct. So in GB, then we have 17.28 GB. So, of course, those that have given our the figures, this is what you have done. You took 28.8, which is MBs. You multiplied by, okay, sorry, I think my figure there should be 0.8. You multiplied by 10 minutes, but each 10 minutes, each minute is 60 seconds, because the original figure is in per second. So you have to multiply by 10 minutes, and each minute, of course, the number of seconds is 10 times 60. So that gives you your figure that you gave there, which was 17.280 MB, which then can be converted into the GBs. So it is equals to 17.28 GB. So you notice that is not a small size. So if you are just relying on most of the ordinary phones right now, the majority of phones people are using at 8 GB, which is small. You notice, therefore, you can't actually, most of the phones cannot record a video. Of course, you would not use a video, a serious video, you cannot use your mobile phone. Because, of course, again, the other problem is that it may not show a full screen, because its resolution is, of course, small. But, of course, if it is like this, then if it can do the 600 by 800 by 600, then it will still give a big screen. But anyway, so most of them may not reach that size for a video. I mean, a mobile phone video. But anyway, that's how we can calculate the size. So if you record your video for 10 minutes, then the size of your video will be about that size, 17.28 GB, which is quite a size. But remember, most events people record for a long time. And so you need the bigger capacity, storage media. Bigger capacity storage media will be required, so that you are able to record and store your image. And of course, the other issue about the images is if you want now to send this image to somebody else across the internet, so that will also be an issue. So how long might it take? Now, because now, suppose you are streaming it, you need now to know what is the speed of the internet that you are using. What is the speed of the internet you are using? So how long might it take you to transmit this image across the internet? Okay, so some of these I'll leave it to us to work at our own time. But let me just put that statement here. Just to put some things into perspective. I don't intend us to calculate this one, but just to put, and some of the questions that normally arise is that you may be asked, so suppose you are to send the image, which is 17.28 GB over the internet. And your internet speed is, let's say it is a 500. Now, most of us don't have that high. So let's say 10 Mbps. Okay. 10 Mbps. That means 10 megabits. Remember, these the small b's is bits, not bytes. Now, so when you are given these figures, you need to be very keen on how they are described. Is it using a small b, or is it using a capital B? Now, M, it doesn't matter because M is simply means 1,000. But the others, it matters. You know, the B, is that bits? Is it bytes? So you have to keep remembering the difference. So if your internet speed is 10 megabits per second, and again you need to know whether if you are given the internet, you are buying internet, are you is it showing what we call for uploading, or is it for downloading? Now, but of course, the assumption here is that this is for uploading. So you are sending that image across the internet to somebody. You know, maybe somebody came to the event and said, "Now, can you send to me the video that you took?" And say, "Okay, yes, I'm going to send it." So how long would it take to have this image, a video, sent to wherever it is being sent? So suppose you are to send this image over the internet and your internet speed is 10 Mbps. So how long? Okay, now let's say, I think normally it's better to talk about it the other way around. Suppose you are to download this image. So let's say, I think, anyway, now we may not be able to change. So anyway, let's just talk about that. Now that's actually the wrong thing. I think I did the wrong thing there. We may not be able to recover that. Sorry, I think it's here. Sorry, I lost it and I can't write it again. But anyway, you got the picture there. So let me just highlight just a few. Now let's talk in terms of downloading rather than uploading. So suppose you download this image. Suppose you download. I think that is normally most of the time we talk about downloading. Download this this video. Okay, suppose it is at YouTube. That thing. Let me reduce the size of my text there. So suppose you download this video and your internet speed let me just call it your internet for the sake of time. Your internet is 10 Mbps. Okay. So how long would it take to download this video? Okay, video is the same, the one which we have just calculated. Okay, so is the video that we have just calculated. Your internet is 10 Mbps, so how long will it take to download this video? So how long Okay. Well, I don't intend us to calculate it, although I can see Mike Jr. has already an answer there. 28 minutes and 8 seconds. Yes, well, I don't know. I have not calculated, but I will assume that you have done it correctly. Yes, so, but these are some of the questions that can be asked also if somebody is downloading. Now, what I am saying is that it's very, very important that you make sure that you capture what you know, the symbols here are going to be very important. Be keen to look at the symbols. So if it's a small b, it is bits. If it is a capital B, it is bytes. Most of the time, the speed of the internet, we use the small b. So it is bits. Most of the time, the speed of the internet is described in terms of the small, I mean the bits rather than the bytes. And so if you can remember that, it could almost be obvious that you are dealing with the bits rather than the bytes when you are describing the speed of the internet or the values that whoever is the source of that description is likely to be talking about bits rather than bytes. Okay, so well, Mike Jr., if you are correct, then and we'll take it as that, unless there is somebody else that has calculated and you have a different figure. So according to Mike Jr., you are going to take, your downloading will take 28 minutes and 8 seconds. For now, you have to just accept it like that, but please try to work on it again, everybody, so that you are familiar with what has gone on. So that one, I'm leaving it as an exercise, unless you have already worked at it and you have found the same figure as Mike Jr., then that's also okay. All right, so let me mount back the document as we get towards closing our session for today. We will not extend it for long. But that calculation is important because there's an area that comes often in an exam. How to calculate the size of the video, or how much space you need to store it, or how much will it take for you to download it across the internet. Those are very popular questions that come now and then. Okay, so let's mount back the document as we close, so we can just highlight one or two other things. Okay, the system is good. Today is loading very, very fast. That's good. We appreciate that. We appreciate that things are good. We thank God for it. And those that are the team that is giving us the technical service at the campus. So these some few things that we need just to, as we get to the close, is that now video is the same thing that we get from the TV. Of course, it's based the images we see on the TV. Of course, also quite a lot of them are based on the things that have been recorded by on video. And when it comes to the TV proper, of course, there are some standards that are used for developing the images that are are shown at the TV, because the TV is essentially a similar technology as the one which is used at the computer. And so there are certain standards that have been there existing, and when it comes to the TV, we talk about the broadcast video, and the standards are there. So I don't want to talk about this. This I'm just highlighting for the sake of information that we have different video standards for displaying the images on the screens. That we have what was called the NTSC standards. But these were mainly the analog for the analog video, the analog videos, of course, or they were meant for analog displays or displaying something that was analog. So we have also we also have PAL and SICAM, and they are described their differences. So we don't want to take so much time about that. Of course, when you shoot the video, there is a lot of editing to be done. Normally, somebody records a lot of details, and some of them may not be relevant to whatever you want that video to be showing. So we have to do some video editing. So I will leave a lot of these to the student. Please read a lot of these, and as a part of making sure that you are well informed about the video technology and what are some of the considerations you may need to make when you are adding a video to a multimedia presentation, when you are creating the presentation, a multimedia presentation, and you want to add video to it as well, then you need to make certain considerations. Now, the other important thing is about compression. As we said, since the video becomes very big within a short time, then sometimes you have to do compression. So we have some compression technologies to reduce the amount of size of video. Of course, you can have we can call a master copy, which could be very big. But when you start now using it for certain purposes, you need to compress it so that it does not demand a lot of space. Now, of course, I'm sure you already experienced this. Last week we had a challenge. Actually, we had a challenge because after doing a lot of video sessions, through the this system called the Big Blue, the BBB, the Big Blue button. Already a lot of data was being stored because you see we are actually taking a kind of a video. This is a video conference anyway, so a video is being taken so it could take, or it was using a lot of space, and within a short time, a lot, the space was used up, and we had a challenge last week. And so we are trying now to, of course, we did not do the compression, although and of course, even with the compression, the video is still big. But anyway, one of the ways of dealing with the size is to do compression. So there are compression technologies. So he's talking about video compression here. So there are different approaches that are used. So a system for doing compression, whether it is software or it's a software, and also the hardware for doing the compression, we call it codec. And of course, we use the same word for compression. Even music is the audio can also be compressed. So we call it codec. The compression. So codec is a compress and decompress. So when you do the compression, when it is being played, or now somebody wants to watch, it has to be done decompression to do a decompress. So that's why we get the word codec. So we have to do that. Now this compression can be lossless, and it can also be lossy. Lossless means that during the compression, that if it is lossless, then you get the same quality of your video as it was before the compression. So you have not lost anything. You have not lost any the quality of your video. It is exactly the same. But if it is lossy means that you lose some quality of your video. When it is now being viewed, it is not the same quality as it was before the compression. So some quality is lost, and so we say that that is lossy compression. Now it all depends on the technology that is being used, and have a number of technologies. Now with lossy compression is also called spatial compression. So spatial compression normally results in lossy compression, spatial compression. And what it does is to remove parts of your, essentially it removes some of the pixels, so to speak, from your image. It removes some of the pixels from your image so that, and of course, in the parts of your image, the images that are shown by your video, there are certain parts of that image that the eye cannot notice so much difference, and so that is normally the parts that will be removed. Especially if there's a space that is just color, there is nothing else other than the color, just showing color and nothing else. But of course, even where there is an image again, but it's mainly about some space that is like the same throughout. You know, like is a lot of blue, a big space that is just blue and nothing else. Then those are the parts that are normally affected, or the compression uses such parts, removes a part of the pixels. Of course, you mean that if it's a color blue, it means that the final image, when you view the image, it will not be the same blue. So of course, I want to guess it will be called a shade of blue. And of course, it does not affect the story. So if the story is that the ball is being kicked, the ball will still be kicked. But you know, that may be the main story. And so the eye does not notice so much that it's so much different, because even the eye is not so much interested with some of those details. It is more interested with the story that is going on. And so depending on how we want to use that video, that's when we decide. Of course, sometimes it's not an issue of deciding, but that's in most cases, that's sometimes it's an important issue of deciding what quality of video would you like it to be. If some of the pixels are removed, does that affect the type of work you want? We want at the end when you watch that particular video. So there are some cases that those are not so important details, and that is where we can use spatial compression. So spatial compression results in lossy compression. And of course, it is explained a little more there. I will let you later on read and slowly, keenly, and capture exactly how does it happen. How does spatial compression happen? So there is this other one which is called or described as temporal compression. Temporal compression. Temporal is a word that is associated with time. Temporal. You remember the word temporary. It is a temporary thing. So this word is associated with the time. So temporal means that it has a factor of time. It is something that is related to the passing of time. So temporal compression normally results in lossless compression. So the temporal compression results in lossless compression. So compression is done by removing similarity between successive video frames. Remember, this is about storage. You want to make your video be able to fit within a certain space. You don't want it to eat too much space. So how do you deal with that? And that is what we are doing, the compression. So you can either do a lossy compression or a lossless compression. So temporal compression is just removing similarities. So what you do, you store a main image and which you use as to display the other images. So you only store one image, but for the other images, now let's say, for example, let's say the 30 frames per second. So if the 30 frames per second, maybe you might just store the first one, and then the rest, the 29 or others, you don't store the images. Instead, you store the differences that are there between the rest of those 29 images. So you only store the first one, and the 29 you only store differences. And so it's like you are having only one image, but which will actually be used to display all the others. So you just store the differences. So it says compression is done by removing similarity between successive video frames. And so that way, you end up reducing the amount of space that you need to store that particular video. But of course, it is now rebuilt back when you are viewing the image. So it gives you exactly the same quality as the original image that was stored. And so we have a different video compression flavors. Of course, these are technologies that come from different companies. And now, when it comes to the compression, we have two main compression technologies. One is called JPEG. So JPEG is lossy compression, while MPEG, and of course the names of the acronyms is explained there. So JPEG is lossy, but MPEG, which is MP4, it is MPEG is spelled as MP4. When you look at the way the images are, the videos are described, you see something written MP4. So that is MPEG. So this one is lossless compression. JPEG is lossy compression. Now the other ones are not a compression. These ones are the videos, except of course it's also in the list here. But most of these others are the videos as they are recorded initially, with all the big size images. So most of these are big size images without any compression. But of course, MPEG is compressed video. Now I want to believe that that is very, very sufficient for today. Let's read the question. So please read the whole document so that you can capture some of the areas that I have not highlighted during our discussion. But that I think is completely enough for today. Any question? So if there is any question, then we can address that. So let me remove the share now. I've actually taken longer than I thought, but some of these are important to highlight, and it takes some time just to make sure that we are getting the important details. So any question or any comment, point of clarification before we wind up the session? Yes, any question? Otherwise, we should be winding up our session for today. That was important to just work, especially the calculations. That always takes a while to make sure that it's clear enough. So I think for the sake of this video, we're going to adopt Mike Jr.'s, I don't know that, yes, Mike Jr.'s value. Well, no, let's say, I think let you calculate that and put it at your own time. How long will it take to download the video? Okay, now just as is Okay, just as an Otieno there, Otieno is asking, how do we compare frame rate according to their frame? It says frame per second. I think there, Otieno, you need to correct that. It's FPS, P for per, frames per second. But essentially, this is you have to look at, these are the same things that we take. Now, suppose you are buying a phone. If you are buying a phone and you wanted to, you maybe have an interest in using it to take some photos. You see, it's you who decides what type of camera, video. I mean, not video, but the camera it has. You who decides how what quality of camera you want it to have. So it is a matter of these are devices. So the devices are the ones which determine the quality. And so you decide. So when you are going to the shop, you need to be thinking ahead what quality of, because it's now about video. So what quality of video do you want? And so it is not you decide, you just have to, you decide, of course, the quality, but that is in the device that you are going to buy. So that whatever you are going to buy is already quoted its quality. So the same thing, remember with the phones, we talk about megapixels. So you say, what is the quality of the megapixel for this particular phone? So it's the same thing with the camera for video recording. So you have to decide you yourself what quality, and then you go looking for that. So just as the phone. And yes, just as is also asking something there, I'd like to ask to clarify the calculation about time that it would take to download 17.28 yes, just as Mokwa, you still want us to do that, but it's a simple calculation. Of course, it's just that we did not want us to do it, but let's see. So how long will it take? So first of all, you need to know the size. Okay, so the size is that according to the one which we are using. So this you want to transfer all this, download all this. So if your speed is 10 megabits per second, it would be best to make sure that you convert to the same unit. Either convert your 10 Mbps to GBs, but of course it's better the other way around. It's going to be a little confusing. It's better you convert these GBs to bits. Okay, convert these GBs to bits. So of course that is not a very difficult calculation. So you go to, first of all, make it to bytes. So you multiply by. Now it's a very big figure, so I don't know which is better. But for the sake of being careful in your calculation, say the size of video in bits is equals to, sorry, I think that's too big. It's going to create a problem for us, the size of the text. So let's reduce it. All right, so the size of video in bits, let me expand this so it can also see. Okay, size of video in bits is going to be 17.28 GB multiplied by, you multiply by a billion. All right, you convert GB to bytes. Okay, so this will be when you it will be by a million, or let's put it 10 to the power 9 for now. I want to believe that you will not get confused when I use okay, now the problem is I cannot use the power. So multiply by, so this is 10 GB. I mean, sorry, you already have this. So we just go ahead and put times a billion. You see, when you multiply by 1,000, you make it megabytes. When you multiply by another 1,000, you make it kilobytes. So you need to multiply by another 1,000 to make it bytes. Okay, so these now are bytes. Then multiply by 8 to make them bits. Multiply by 8 to make them bits. So this now will be bits. And from there now it is just to divide. Remember now from there it's just to divide by the 10, because 10, so per second. So because we are transmitting. No, remember, of course, also the other one is in megabits. So I think we should have put it in megabytes. We don't have to go to billion. I think we just needed to multiply by 1,000 to make it megabytes. Okay, so megabytes. Okay, but this is bits. Okay, yeah, that's the reason why you have to make it the bits. So megabytes. Okay, yes, since we are talking about megabits, we can keep at megabytes. So megabytes, because we still go back to that. So this at this point it is GB. So we have just that to make it megabytes. Okay, at that point it's megabytes. So just multiply by 1,000 megabytes, then multiply by 8 to make it bits, megabits. Okay, that is megabits. But to avoid confusion, let's still keep it at the billion. I think for most of us, just to avoid the confusion. So let's keep it just straight bits. So we have a billion. Okay. So 9 zeros. So that's bytes, and then make it bits. So that is now this is just bits now. So from there now you divide by you now divide. So you do this figure, whatever that figure is. You need to divide it. So I don't know whether you have been able to do the conversion. So this is the time. So time equals this figure, whatever it is. Let me call it. For now, I'm going to just, of course, because of writing here, I'm going to just call it a letter here, so that I don't have to write a lot. So let me call this one just size. Okay, so this is size in bits. So what you need now to calculate your time is get size, which is now the whole of these ones. You calculate all this. So what you're going to say, time is going to be equals to size, and the size is, of course, whatever that value is. Size divide. I'm going to use a slash for divide. Divide by what? 10 megabits. So if you want to put them into just straightforward bits, then it is megabits will be 10 multiplied by 10 multiply. So I'm using an X symbol to mean multiply. Of course, that's not the correct way of. So let me avoid that because it's going to confuse us. So 10 multiplied by these megabits. So we want to make them bits, just like they are the top. So you need to multiply by a million to make them bytes. Okay, multiplied by a million. At that point, it is now bytes, and then you multiply by 8 to make them just bits. So you are transferring all these per second. Note that this is going to be per second. No, when you divide, it will be seconds. So at this point, the value you get here will be seconds. So remember here, now we are calculating time. The time it will take to transfer our video using that internet speed. So times 8. So that now we have bits. You see, you need to make them same unit. So here they are bits, and here they are also now bits. So every second you are transferring 10 megabits. Every second you are transferring 10 megabits. So if you are transferring 10 megabits every second, so how long will it take to transfer all these bits with your internet speed? And so it's a division. So whatever you get here, then you divide by 10 times a million times 8. So this again is the bits now. Instead of talking of in megabits now, this is now ordinary bits. You say these bits per second are being transferred per second. So this particular calculation as it is should give us time in seconds. So whatever you get here will be the time in seconds. So depending on maybe what the requirements of the question, if the question says give your answer in seconds, or give your answer in minutes, or give your answer in hours, depending, because maybe this is going to take a while. So I don't know what. So I think even from our screen, we may be able to calculate that one now. Notice that when you do the divisions, we have a whole 6 zeros that will cancel with the 6 zeros here. And so, and of course, the 8 here will cancel with these 8. So you're noticing it's becoming an easier mathematics to do. So you'll be left with 17.28 times having followed by 3 zeros, but 2 of the zeros will be eaten up by the decimal point here. So finally, it will be 17,280 over 10. 17,280 over 10. 17,280 over 10, which finally will become 1728 seconds. Okay. So I think when you look at it, the mathematics is becoming easier now there. So finally, we expect it to be 1728. Is that correct? Yes, 1728 seconds. But you need to confirm that because I'm not doing it very, very keenly, so I could make a mistake. But anyway, that's a process that you need to do. So remember, so this part here, this 8 is to convert your, oh, sorry, I think I made a mistake. This is already bits. So sorry, you should not multiply by 8 here. That's a mistake. So notice that these are already bits. So we have made them megabits. The only thing that is already in megabits. So we are only calling it now bits rather than mega. So these 8 should not be there. So we still have an 8 here to multiply with, not divide. So we still need to multiply this by 8, sorry. So I hope you have followed. This one is wrong. Right. Unfortunately, we can't wrap so easily here, but we can mask. Let me mask this one. So this one should not be there. So let me try to just mask that. Remove it from this calculation. That was wrong. Okay. All right, I can't I can't remove it that easily. Okay, there is a this rub. Sorry, I've not looked at what can help to remove something. And so, but just want to make sure that it doesn't give the wrong information here. So how can we remove that? Anyway, make sure that I hope that does not confuse you. I'm trying to see if we can remove this, but it is not possible. So anyway, remember that this should not be multiplied by 8 because these are already bits. So this final answer here, therefore, should multiply back by 8. Sorry for that. I hope you have followed how I'm trying to correct that situation. So this one should be, because we had multiplied by 8, we have put an 8 here. So this one need to take it back. The 8 should still be there. So the 8 that we had earlier on, we need to keep that 8 here. And so this figure need to be multiplied back by 8. So 1728 needs to be multiplied back by 8 so that we can have our figure. So the final figure, therefore, should be that multiplied by 8. So I don't know what was Mock was figure there. So you need to multiply that by 8 to get your final figure. I think you can do that for the sake of following this calculation. I think since it's just a single 8, 8 times 8 is 64. We carry 6, we get 16 plus 6 is 22. We carry a 2. Sorry. Over 4. Oh, this number is expanding up, going the other direction. So you have a 4. 22. Sorry. 22. Then we have 8 times 7 is 56 plus 2 is 58. Oh, sorry, the number should be 58. And we carry a 5. Then 8 plus 5 is 13. Sorry, these numbers are. Okay, so that's what we should expect. If I did calculate this now correctly, and this is in seconds. This time in seconds, 13,824. So I don't know what did Mokwa give, or who gave us a value. It's Mike Jr. 28 minutes. So is that 28 minutes? Yours is in 8 minutes, eh? Anyway, so but that's how we should calculate it. So, but confirm, because I may have I'm not doing it very carefully. But anyway, in terms of the steps, those are the steps. But remember, here you should not multiply by 8 because this is already expressed in bits. It's megabits. So the only thing that we needed to is to expand it to by 1,000 to make it bits. So 10 megabits, now it becomes 10 times a million to make it bits, because mega means bits. I mean, means a million megabits. So multiply by a million to make them bits, and then you do the division. So again, you notice there for a million, you just cancel a million from the top, which will leave you with 17. Yeah, so this actually should, sorry for the confusion. This actually should be 17,280 by 8. Because once you cancel the million here, you'll still be left with 1,000 here. And when the 2 zeros will be eaten by the decimal, so it should be 17,280, not 1728. It should be 17,280 times 8. So I don't know how. Okay, it's because now we are dividing by 10. That's why. Okay, so now I see. It should actually be this way. Because after the 17,280, you are dividing by a 10. So that's why it will be 1728. Then times 8, this 8 here. This 8 is the one which is we are dividing, we are adding here to multiply by 8. And so it will be that. Then you divide by 60 to see the minutes. Now this looks like it's going to be bigger than what Justus has given us. Is it no, Mike Jr. Yours is 28 minutes. If you divide that by 60 to make it minutes, I think it will be bigger than that. But anyway, I hope you have followed. This is I'm trying to follow the question from Justus actually. Justus has asked that calculation. So by the look of things, it looks like it's going to be bigger than 28 minutes. So Mike Jr. also tried to check again. Then Otieno Brown is asking an example between one with 30 FPS and another with 24 FPS. Which one is better? Now, of course, the more the frames, the better. Okay, in terms of the quality. Okay, the more the frames, the better. But the problem is the space. Okay, it's just like we can say an image, the more the pixels, the better. But what about the space? It is going to eat up more space. So in terms of better, I would say the one which has the higher FPS is better. But you have also to be thinking, so you have to do a balance between the quality and the space that it is going to require for storage. Okay. So any other question? All right. Just as now recalculated it, and yes, just as has and also the same with the Otieno, that the figure is 13,824. Then of course, if you convert it to the minutes, then yes, you can notice it's not a small figure. Just as that calculated at 230.4 minutes, and then converting that one to hours, again divide by another 60 to make it hours, and then just as says it is 3.84 hours. So you notice that challenge. If your video is that big, 17 GB, and then you are using that speed of internet, then you see it's going to take you quite a while. A whole 3 hours is not a short time. But anyway, this is and of course, this is what happens, especially if it is not. You see, that's why the compression is important. You find that, of course, most of the videos you are going to get from the internet, they are already compressed. When they are compressed, then it takes a shorter time, because what you download the compressed format. But when you watch, it is decompressed. When you now double click to watch, it is again decompressed, so that now it is all the pixels again. Okay, so thank you so much for being present and participating this way. It's great to have had you for this particular lesson. Now, there is already an assignment 1. I hope you have already done it, but if you have not done that, please make sure that you do it. Assignment 1 is already at the portal. has been there actually for a while. Make sure that you finalize it. But there is also a discussion forum, which I would like you to make a response to before you leave. But you can also come later on just in case. But I think we have taken longer than I actually had thought. So it's not, I may not require you to handle it immediately, but make sure that it is actually, you do make your response at the portal for the discussion forum. Then also just information that we may need to try and look for a time that we can do a makeup, because we have missed quite a number of sessions during the exam times. But I'll also be putting up our assignment 2 and our CAT 2 probably before the end of the week. So we'll be informed, especially the CAT 2, but the assignment 1 that may be allowed some time, but the CAT may be required to be done in one sitting. Okay, so otherwise, I think that's sufficient for today. For now, I say thank you once again, and enjoy your afternoon. Goodbye.